Section 4.5 is the last matrix section that we did. We were finding inverses of 2 by 2 matrices and then using matrix equations to solve systems with 2 equations in it. So the first one, we're going to find the inverse of this matrix. So in order to find the matrix, you need to first find the determinant. So we multiply the main diagonal. 2 times 8 is 16. Minus, multiply the other one, 5 times 3 is 15. Remember to always subtract. 16 minus 15 is 1. So the determinant is 1. Let's call this matrix S. So the inverse, S negative 1 means inverse of matrix S, is 1 divided by the determinant. Our determinant is 1, so we just get 1 over 1. Multiplied by the matrix, so we have to revamp this one a little bit. We switch the two numbers that are along the main diagonal, 8 and 2 trade places, and we change the signs of the other two. So 3 changes to a negative 3, 5 changes to a negative 5. So if this were something like 1 over 7 or something, I would just leave it out in the front, because if I'm going to have to multiply it by another matrix, I would rather multiply the integers first and then do the fraction. This one is just 1 over 1, so it's just 1. And if you distributed 1 in, because it's a scalar, it wouldn't change anything. So the inverse of matrix X is 8, negative 3, negative 5, 2. Then we were using those inverses to solve a matrix equation, or to solve a system using matrix equations. So the first thing I notice is these are not in the same order. In order to use matrix equations, you have to have them both be in the same order. You need the x's and the y's, and then equals the constants. So for this bottom equation, I'm going to move the 2x over. You don't have to have x first, but they have to be the same. So if this one has the x comes first, and the other one, when I move the x over, I'm also going to put it first. Okay. So now first step is to write a matrix equation. So I have, remember, the coefficient equation, 3, negative 1, all the coefficients, negative 2, 1, multiplied by the variable matrix, the variables are x and y, is equal to the constants, 4, 5, negative 4. So here we have a coefficient multiplied by variables equals a constant. And I keep going back to that basic example we did, the very first one we had in our notes that day, that was 1/2 x equals 4. If you're trying to solve for a variable, you need to get rid of the coefficient. You need to cancel that out. And to do that, we multiplied by the reciprocal, because that's the inverse. So we multiplied that side of the equation by the inverse, and they cancel. And then you also have to multiply the other side by the same inverse. So we're going to do the same process down here. It's still an equation. Here are our coefficients. Variable equals a number. So we need to find the inverse of this matrix so that I can multiply it, and they will cancel each other out, and we'll be left with x and y. So this 2 by 2, the coefficient matrix, is the one that I need to find the inverse of. So we need to find the determinant first. 3 times 1 is 3, minus negative 2, and negative 1 is positive 2. So 3 minus 2 is 1. So again, we do 1 divided by the determinant. Since it's 1 again, I'm not going to write it this time. 1 divided by 1 is 1, and when I multiply that by the matrix, it doesn't change it. So I have my little 1 over 1 in front. That's not going to do anything. Now go back. The main diagonal, the numbers in the main diagonal trade, so you get 1 up here, 3 in the denominator, and then you change the signs on the other two. So that negative 1 in the top right corner becomes positive 1, the negative 2 becomes positive 2. That is the inverse. So I'm going to multiply that inverse on both sides of this equation. I'm going to multiply it on the left-hand side. So there's the inverse. We'll label it. That's the inverse. we had the coefficient matrix, our x and our y equals, now if I multiply one side of the equation by the inverse, I have to multiply the other side of the equation by the same thing in order to keep it equal. So there's the inverse on the right-hand side, and I'm multiplying it by the constants that were already on the right-hand side, 5, -4. So when we multiply a matrix by its inverse, they're going to undo each other, cancel each other out. You'll get the identity matrix. So I'm just going to cancel those two. These cancel. So those two cancel out, and you're left with xy is equal. Now you can multiply these out and make sure you get the identity matrix, and that would ensure that you got the right inverse. I am going to this time assume that I had the right inverse. If it were a test, then I might do it differently. I probably would double check just because I'm uptight like that. But for this, I'm going to assume that I did the inverse correctly. So when you multiply on this side, it cancels. Then on the right-hand side, you actually have to multiply it out. This is where your answer's coming. So when I multiply these two, I'm going to get a 2 by 1. Multiply 5, -4, subtract, and you get 1. 10 minus 12 is -2. So that tells you that x is 1 and y is -2. Remember, you can go back up here and check. You can always go back up here and check. If I put 1 in for x, 3 times 1 is 3, minus a -2. That makes it +2. 3 plus 2 is 5. Yay, we're good.